in terms of the agenda, we're going to do a quick overview around the 4100i. Then I'm going to provide some details around that, so dive in a bit more around the 4100i because it's really has a lot of physical parameters around it that you have to be aware of. And then we're going to bring out some of the sort of marquee features or some of the notable features on the 4100i. And then I'm going to do a small demo, which is more of a show and tell around those marquee features. And then Ed's going to do a bit of a live view or a walk around one of the switches for you, and maybe answer some questions at the same time. So without further ado, let me introduce these two switches. So these are what we call a ruggedized switch. It has a CX operating system on it, as you'd expect. We have two switches, and you can see we've got this sort of cubey type of switch, different type of form factor, which is a DIN mountable switch with associated power supplies. And then we have a 24 port switch, really. So there's two switches. And really the most interesting part of this is really it's how they're built and what the internals are and all the hardware around it. So they are layer 2 ruggedized switches, so really layer 2 features. They have an operating temperature between minus 40 degrees C and 70 degrees C, and it will depend on what you've got plugged in, especially around where you have to consider SFPs here. They're IP30 rated. I'll go into that a bit more. You also support BT PoE, so up to 60 watts in these switches as well. We do support dynamic segmentation as well. And of course, all the management features that you'd expect in CX. We have central and NetEdit and REST, etc. So that's really a quick overview around the switch. So let's dig in a bit more. So where are these switches positioned? So what we say is that we're going from the intelligent edge into sort of non-carpeted space, basically. So we're talking about manufacturing, smart cities, warehouses, transportation, etc. So if I give you an example today, in large public venues or in harsh environments, we might have outdoor APs, but we don't have an associated switch to possibly go with that. You might have corner cases where you need to bring the switch closer out in a harsher environment. You can now do that because we have these ruggedized switches that can be put in cognizant with the APs, for example. So if we talk about smart cities, we have compliance to what's known as a NEMA TS2 enclosure. So we can put our switches in these enclosures and we can use them for various smart traffic applications. Even in things like substations, we have surge immunity and protection for those switches under certain circumstances. Again, something we didn't have before. And when I'm talking about transportation, we're talking about you could possibly put them into rolling stock or possibly on track side as well, where there's high vibration. And again, you've got outside temperatures you have to contend with as well. So this is what we're talking about in terms of the switches being able to be brought out to these areas. We also have redundancy in the switch as well. So we have power redundancy available on the cubed switch, which is the DIN mountable switch as well, which is quite interesting. So we have power redundancy there too. So in terms of industrial type of specific standards, you've got to refer to the data sheet, but here's an example of what we have today, just a subset of that. So there's a whole load of industrial standards we comply to, okay? For instance, substations, railways that I mentioned earlier, and traffic control systems. But if you think about things like voltage surges, dips, ripple, interruptions, vibration and shock, electromagnetic pulses, electromagnetic frequency, radio frequency, we have compliance to certain standards which you need to refer to the data sheet, especially if you're answering RFPs or customers asking you questions, which will always be updated and kept up to date. So please look at the data sheet for those details. So let's look a bit more into these switches. As I said, these switches are IP30, and what that means is the ingress protection of this switch, 3 meaning the physical and 0 means the second digit means protection against liquids. So in terms of protection against physicals, we have protection against objects around 2.5 millimeters, but there is no protection against any type of liquid or water. And these switches in harsh environments are expected to be put into a protected enclosure. So if you've got dust and you've got water splash, you need to put them in an enclosure. You cannot have them in those sort of contaminated environments just out in the open. And that's really an industry practice anyway. It's standard. It's what the market has anyway. So we're sort of conforming to that. These are both layer 2 switches, and how I position this, it has the same features as the 6100, but with a sprinkle of a 6200 in there as well. So that's, and I'll cover some of those salient features. Important thing to understand with the DIN mountable switch, you must use one of the 3 external power supplies. So this comes with external power supplies, and I'll cover those in details a bit more. But the main thing is it's a layer 2 switch. We've got 12 and 24 ports. Conversely, both have 10 gig up to 10 gig uplinks, which are 2 on the 12 port and 4 on the 24 port switch. And very interesting is these are passively cooled. These are totally fanless. There are no fans, and it relies on the heat sink to be cooled. Again, I've said about the BT PoE, free PoE power supplies. So there's redundancy only on the 12-port DIN mountable switch. You have to be cognizant also of there is some derating going on the PoE power, depending on various factors, which I will cover later. The 24-port switch, we'd expect that just to be typically in a rack in a controlled environment, but can also go in cabinets too. Typically, you'll see these in cabinets, but this gives us a lot of different opportunities with the 24-port switch. Okay, so let's look at closer in terms of these switches, in terms of the ports, because I've picked out some areas that are different that you don't see on our normal CX switches. So the first thing is we have two DC inputs on the 12-port switch. So this provides us the redundancy, or the opportunity for redundancy, and this is only DC power input goes into that switch. Whereas a 24-port is a regular receptacle, but notice that it's in the front of the switch. So this is the first CX switch that has a front formed power input. And this was demanded by some customers, and we did some research and worked with customers for that specific item. And then we have this ground lug. It's mandatory in a lot of environments. You've got to have this grounded. It has impacts on other setups as well. So you must have them grounded in certain scenarios. Really most scenarios you should have it grounded. It will be a corner case if you didn't have it grounded. Okay, so a big ground lug for the 12 port and a smaller ground lug for the 24 port, and then we've got the SFP plus modules here in point 3. Point 4, we've got the PoE modules. So we've got the 4-port PoE, which has got a little bit of a silver surround on it. And then we've got these dry contacts on both switches, and I'll cover this in details. These are input alarms and output alarms. So here on the 12 port, and obviously located differently on the 24 port. And then we've got the new LEDs that register these alarms on both switches in area 6. And then 7, we have now an RJ45 console connection as well as the USB-C. So you've got both options on both switches for effectively a console connection. So really that's the sort of salient points that are sort of different to other switches. So we talk about the DIN rail mount. So obviously some of you may not know what this is, so I wanted to cover this off. So DIN is defined by the Deutsche Institute for Nuremberg, and this was a really old standard which translates to German Institute of Standards, and basically this has been adopted by the industry, especially in industrial areas. Now you have different types of DIN rails. So you have like a G type, you have a thin form factor 15 millimeter, but what we support is the most common standard is a 35 millimeter top hat, and you can see it's called top hat because of the shape, and the 35 millimeter is from brim to brim effectively. And on the left I've got the different type of standards that are referred to in the different regions. So the main thing is that if you're going to be installing that, it's got to be a 35 millimeter top hat DIN rail. Now the DIN rail can have a slightly different depth, maybe 13.5 millimeters. Again, that would be supported as well, because the main thing is the 35 millimeters from brim to brim. So that covers off DIN rails. One of the things we do say, depending on the scenario we're installing those switches, you have to, we say we prefer to have steel or stainless steel DIN rail mount for high stress situations. Otherwise, we really aren't compliant. So it's also about having the right DIN rail. We also have a DIN rail kit that we supply that we can put into a 19-inch rack, and here is the DIN rail that comes with it. Another important thing about this switch is when you're mounting it, it comes with the DIN rail attachment at the rear. So you can move this DIN rail attachment to the side of the switch, and then you can move this cover as well. So the cover can move from the side to the rear here. Now, the reason we do this is because if you're in a deep or a shallow cabinet, if you're in a deep cabinet, yeah, you can use this rear mount. And if you're in a shallower cabinet, because of the radius bend of the cables, you can go to the side. Again, this is a sort of USP we have, and we work with a couple of our customers to help us design this. So you won't see many switches, or I haven't seen any switches that really do this with this port density and with PoE. So again, it's a really good USP for this switch. Now, if you're going to be putting this in a high stress environment, we also supply a specialized attachment which attaches to the rear of the switch to help us in more dynamic stress installs. And you can see it's attached to the back of the switch, and then this is sort of a clamp onto the DIN rail mount, and then it also screws at the front. Now, this high stress environment is only supported on a rear mount, not on a side mount. So I talked about the the external power supplies. So, and we've talked a lot about dimensions. So dimensions are really, really important. Now this switch, the 12-port switch, is generally bigger than all of these power supplies, apart from the width of the 480 watt power supply. So you have to be really cognizant when you're doing an install of these switches that you can accommodate the switch as well as the power supplies. And if you're putting a redundancy in, you've got to accommodate two of those power supplies. And I'll talk about redundancy in a moment, but I've put the dimensions here, which you can pick out from the data sheet, and the weight. It's really important because if you think about it, the dimensions are provided with the DIN mount, and then you add another 10.6 millimeters into that enclosure or wherever it's being installed when you put the DIN mount connector on the back to install it. So really you need to be cognizant of how you're installing it and where you're installing it. This power supplies have to be in relative proximity to the actual switch. So we're saying approximately 2 meters is the furthest distance the power supply can be from the switch. And it's detailed here, and also the types of cables that are used for the switch. So there's a DC input here, so that's 14 AWG. For the AC power, so we do supply the cables that go between the switch and the power supply, but what we do not do is we do not supply a cable that goes for input. So if you've got an AC input, you have to strip that cable yourself. And we've put the specifications of what that cable should be between 16 and 12 AWG when you're using the AC power supply, and then 14 AW, 12 AWG when you're using the DC power supply. One more thing to remember is that the height of this is around 3.6 U. So if you're putting or installing it into a 19-inch rack, you need to allow more than 4 U just for its space. And that doesn't include the space above and below it as well. We need an inch above and below it. So really, typically, rule of thumb, you want to look at 5 U for this switch if you're putting it in a 19-inch rack. So the external power supplies, these have a different product name. These are 4,000 eyes. So when you're using these to power the switch, they have a different PoE budget depending on the switch, the power supply that you're using. Now, there's a couple of factors that are very important with this. It's first of all, the ambient temperature. So for the AC power supplies, depending on the temperature, that is what we recommend the power draw is on your switch. So you can see in this table, if you're at normal temperature, this PSU, the 480 watt, will give you 360 watts of PoE budget, but it will drop to 320 as you go to a different temperature range. We're calling it ambient 60, so it's between 50 and 60 degrees. Now, there's another factor with the DC power supply. If you're using DC power, you have to also account for not only the temperature, but you also have to account for the input voltage coming in. And here in the table, you can read that different DC voltages and temperature dictates the power that you can draw safely for the 12-port switch. Now, very important, we do not support any other third-party power supply or a direct DC into our switches. To be supported, you have to use one of these 3 switches, one of these 3 PSUs for the switch. Okay, so I did talk about PoE budget. Now, there is no communication between the power supplies and the switch, effectively. It's just electric cables. So when you know the environment you're operating depending on if you've got mixed PSU, so you could, in theory, have a mixed PSU. You could have this AC PSU and possibly this one as a backup. And depending on the temperature operating you have to set the PoE power on the switch to make sure that these PSUs operate normally, okay, or in a predictable manner. Okay, so you need to look at the temperature, and if you're using DC, what the DC input is, and it's a configuration on the 12-port switch.
Really important point is, go back one slide, Kamal. Footnote number 1 on the bottom. Unlike any of our other switches that have modular power supplies, putting 2 power supplies against this 12-port switch does not increase your PSU, your PoE budget. Does not.
Yeah, good point, Ed. So having 2 power supplies does not mean you're doubling your PoE budget. It's only for redundancy only. So it's purely for redundancy, no increasing of PoE budget. Thanks a lot, Ed. Okay, now when you're doing some diagnostics around the PoE and the power, I just put this in here, so I'll show you that as part of the demo. So we can see which PSU is primary by the voltage applied, the higher voltage. I've only got one in this demo, in this output here, but typically the higher voltage gives you the primary PSU, and you tweak that by configuring the PSU, depending if it's the digital, if it's the DC or the AC, there's a potentiometer that you need to move. And then you can just see the output of the power supply. You can see what the maximum is of the switch, and then you can see what you've configured. In this, I've configured it, limited it to 320 watts. Okay, very important. I've gone on about all the derating and all that type of stuff, the 12-port switch, and also what PSUs and how you use it or not. With the 24-port switch, you don't need to worry about it. As long as you're operating between -40 and 70 degrees C, you're good to go. Your PoE budget remains. You're getting the 240 watts PoE power for that switch straight off the bat. So another important thing is in certain applications, we might need some surge protection for these external PSUs. So we've tested a number of surge protectors. You can find those in the data sheet. We provide an application note how to install those and the details around how to install those surge protectors. So the surge protection gives us protection for up to 4 kilovolts on both types of power supply. This one's for the AC, and this surge protection is for the DC power supplies. So installing these switches, really important how you install them, where you install them. I did say we would see these in enclosures. Typically, we're showing them in the tightest enclosure here. So it could be in a small lamppost type of enclosure or a wider type of enclosure. The main thing about these, the 12-port switches, is that you must leave a 6-inch gap above them and a 6-inch gap below them if there's a heat source below it, and a 1-inch gap to the side. And again, it's shown in a wider enclosure here what the differences are. You can see there's only 3 inches. There's nothing below it. You'll also find these installed in larger environments. This is in like a 1-door enclosure. You get 1-door, 2-door, and 3-door type of enclosures in an industrial type of environment. So you have to be cognizant around what else is around in that environment. You have to be conforming to about 40 linear feet per minute of airflow within that enclosure to be compliant to the install. And on the right, we've just shown it in an open rack effectively, or in a 19-inch rack. And you need 1U above and below them. Typically, 1U above. But obviously, there's a heat source coming here. If there's no heat source, then you're good to go, and you can put it on a shelf on its own as well. How not to install it: not under a shelf, not on its side, which is shown on the web UI on its side, but that's just showing it on its side. And they do not stack. No stacking, nor side by side, because these are based on heat sinks and passive cooling. And there's been a lot of work around how these devices are cooling, and it's impacting our throughputs as well. So very important how the install goes and how it is set up. With the 24 port switch, again, we still need, in an enclosure, you still need 40 linear feet per minute. Ports must always be down in an enclosure. So no other configuration is supported if it's wall mounted or on an enclosure. Ports down only, and then a 1U gap between adjacent devices and on a tabletop. And how not to install it, hopefully it's self-explanatory.
By the way, we noted that the power plug is, as you see in that upright tabletop picture, the power inlet is on the front. When you do mount and ports down, there's actually a kind of a what they call a bracket, or a little pull-out where you can actually cinch the power cord with this twist type. So even when it's hanging down, it'll be basically secured into the switch. I'll show you that when I show you bigger pictures.
Yeah, it was in the earlier slide. So take a look at one of the earlier slides. You see the cable loop in there, and it's in the install guide as well. So which is going to be out, which is really going to be out when the switch is out. Okay, so sort of Ed's territory anyway right now, funnily enough. So we support 4 industrial type transceivers for these switches. So if you're going to be operating them in a harsh environment, it's mandatory to have our supplied industrial temperature transceivers. Now we're supporting 1000 meg SX, LX, 10 gig short range and long range, and obviously OM2 multi-mode fiber if you want to go half a click, and then the LX supports both single mode and multi-mode fiber. Obviously distances change. Now the industrial transceiver ranges between -40 to 85 degrees C. It doesn't mean the switch is going to operate there. That's the transceiver operation, but the switch is only built to operate up to 70 degrees C. If you use non-industrial transceivers or a third-party industrial transceiver, you are going to get derate logs, you're going to get ambient temperature warnings, and you're going to get transceiver case temperature logs as well when they start rising above 50 degrees C, 45, 50 degrees C on those industrial transceivers. So just be conscious that there's a 3-year warranty on the transceivers, like all of our transceivers, but there's a 3-year warranty on those. So really some notable features. So you noticed that I talked about alarm ports. So the alarm port is an external type of port that you can connect to. So it's intrinsically linked to the switch and controlled by the switch. So we can have hardware alarms that generate an alarm depending on internal or an external condition. And each port can be configured by the user on how it acts. So we can send two types of, well, three types of events. We can send a log, so an event log, so a syslog, and a SNMP trap. But we also have a relay function that can send an external viewable or soundable alarm. So basically, this is the dry contact or the alarm bit, which sort of pops out on both switches. It's got a few things we need to be cognizant of. We have a normally closed connection, a normally open connection, and a common connection, which forms a single circuit. Then we have a dry contact alarm, which is an input 1 and an input 2, and a ground, input ground connection. So that's all fun, but how does it work? So if we look at the normally closed, normally open, and the common, if you think of there's a switch between these to form a circuit effectively. Now this is like a flip switch relay, which will flip depending on certain conditions and how you configured it. Now you connect up a device, which could be an LED, alarm, or buzzer, whatever. I've got a resistor here, and then a power source. Now, if I close this circuit under normally closed conditions, my light or buzzer or whatever it is will ring or illuminate. If I flip the switch, this will go off, and this circuit will then be initiated and energized. So we have that specific circuit, and how that actually is energized is the switch controls it. Now, if I get a PSU fault, I can trigger the relay to flip. When that flips, obviously the alarm or the LED goes off. Also, if my ambient temperature goes above 70 degrees C or close to that, again, I get a flip to normally open. So that's the first scenario from internal events effectively, although this is an external event that we're measuring. So the second circuit are these three contacts. Now, again, these contacts are again connected to this relay, which can energize this specific relay to flip. So these are dry contacts. They don't need a power supply. You connect your wires into here. If it's an open, depending on how you configure the switch, you can make the relay flip as well as send a log and a trap. The same with the PSU and the temperature, you'll send a log and a trap. Okay, so if I was going to close this, it would then possibly send a log and a trap, and as well as sound or flip one of these lights to go on or off. And I'm going to do a quick demo around that as well. So it's really simple to configure. So for temperature, you can set the action to log and trap and or relay. The same for the power, you can log and trap, so send a log and a trap, or a relay and a relay. And all you do is you then configure the alarm input, give it a name. I've called it door in this instance. Now I can trigger that external alarm input 1 for the door to be open or the circuit to be open or closed. And that will either trigger a log and a trap or a relay, depending on how I've configured it, user configurable. And then you've got a snooze option. If someone's doing some maintenance on that device, they maybe have opened the door and the alarm's triggered, you want to be able to snooze that alarm. So there's a snooze option as well. So really important to understand the alarms. I've done a show alarm input, and we can see here I have got input 1 is inactive. I've got it configured for logging and trapping, sending a log and a trap, but I'm not doing any relay function. And my trigger event is when it's closed. In this instance below, input 2 is active, so it's actually activated, something's happening. I've got no log and a trap, but I've just got the relay configured, so the relay will energize when there's an open circuit of this input. And then I've shown it for the alarm for the temperature and the power supply. The temperature is fine, but the power supply, there's been some sort of failure, so it's active, and the relay has signaled to a visual alarm. So important salient feature 2 is obviously dynamic segmentation is one of our key marquee features, which is featured on the 4100i. First release is local user roles. And here's the basic configuration. Really, I've got a UBT zone defined. I've got a controller here. I've got my local role defined, and I've got the role that's defined on my clear pass in this instance and on my gateway, which basically then pushes it down to this interface, which has basically got the .1x configuration. Local user roles, as I said, 32 roles supported, and today we've got 762 UBT clients available on the 4100i. And this is just a show of the UBT state on a specific 4100. You can see I've got the switch anchor controller, and then I've got a user anchor controller because I've had a user working on here, and if I do a show UBT users, I've got an activated users in this employee role. Again, obviously, we support Central on-prem, CLI and NetEdit, and obviously the web UI. Central will be Central 254 when it's released with 10.8, and NetEdit is expected to be 2.1.1 when it's released very, very shortly. Another marquee feature is quick PoE and always on PoE. Just a reminder for those who don't know it, we've created the TME YouTube video, so you should be able to see what that is. Basically, always on PoE for a warm soft reboot when you're powering up, when you're doing a software upgrade, and quick PoE when you've experienced some sort of loss of power and a reboot. Again, by default, always on PoE. Quick PoE is not on by default, but then you can quickly enable that by just power over with it, quick PoE, and you can see that quick PoE is enabled through configuration. Again, very important feature is the mixed PoE. Obviously, we do support 60 watts because we're seeing people asking for heaters and for CCTV cameras that pan, tilt, and zoom. So in sort of harsh environments. So we've got the capability here. It's sort of future-proofing this switch. You won't see many switches doing this in the market right now. So another marquee feature, maybe a must-have actually. So we support DHCP relay and snooping on the 4100i, and here's the basic configuration for that. Note that we also support flash storage of the DHCP bindings, which is a new feature in 10.8. So if the switch reboots, you're going to be able to save the bindings, any sort of power failure, or you upgrade the switch. Again, V2 DHCP relay and V6 DHCP relay. Again, I've covered this all in the TOI in 10.6 around the 6200. There's nothing different apart from the new flash storage feature, but it's in the 4100i. Now, a very important thing is you're going to come across industrial protocols and automation control protocols, things like Profinet, Ethernet IP, Modbus, and BACnet. Now, you've got to remember that these are really distinct protocols that aren't interoperable. They have different types of PHY, different requires for latency, and the Ethernet in this is really, really highly modified. We don't support this out as a native protocol, but there may be situations where you can actually have your switches working in these type of environments. So if you look at things like Profinet, which is really purported by Siemens, then you've got Ethernet IP, which is not IP as we know it. It stands for Industrial Protocol, and it carries common industrial protocols, very multicast intensive, and it's ratified by DeviceNet. So you can look at their website around that. And then you got things like Modbus, which is RS-232 and RS-485 and Ethernet focused. Again, this was like a vendor Schneider, but now it's controlled by Modbus org. And then if you look at BACnet, which is building automation control networks, again, there's a BACnet org, and you have certain standards around that. A lot of RS-485 in BACnet as well. But the positive thing is there's a trend to move towards Ethernet and IP in these environments. So if you're coming across these type of environments, you have to be very cognizant of what you're doing. You have to test and really do a POC around these if you're going to validate it. So if you look at things like Profinet, we have something called Conformance Class. Typically a managed switch or an unmanaged switch can be put into a Profinet network in these scenarios. But if you're looking for some interaction, which is Conformance Class B and C, then you have to be very careful of how you do that. Again, in Ethernet IP, very IGM, very multicast intensive, and the ODVA test and certify switches for those type of environments. Again, you have to be careful in how you possibly position that, but we do have the features which comply to these standards. And then if you look at things like Modbus and BACnet, again, BACnet, they have some sort of BACnet have BACnet labs where they certify products, but not switches and routers. So you possibly can use our switches in a BACnet environment. And the same with Modbus. Again, they are slower speeds, but moving towards IP. Possibly you could use in the environment. But the main thing is please POC test and validate in client-specific environments, because there's 200 disparate protocols that are there. So in quick summary, really, the 4100i is a ruggedized switch for harsh environments. Remember, it's IP30, fanless. We have a DIN mount and a 19-inch 1U switch. We're compliant to industry-specific standards. Remember, we have external PSUs, both AC and DC, offering redundancy on the 12-port switch. And we comply, or we operate between -40 and +70 degrees C, but you've got to use our industrial transceivers if you're using SFP uplinks. If you're using copper only, go ahead. One thing I haven't really talked about, in colder environments, the switch can take up to 20 minutes to boot because we have to wait for the heaters to come on. So there's some heaters inside that switch that need to come on in colder environments for those who are using in the, maybe in the Nordics especially. Alarm input, we have output, we have 1 alarm, output 2 alarm inputs. Again, it's 10.8 first release, layer 2 access switch with a sprinkle of 6200 features in there. Remember, we've got UBT with local user roles, DHCP snooping, always on and quick PoE, 60 watts PoE 2. And remember, we've got console access, all types of console, RJ45 and USB-C, default VRF. So only in-band management for the switch at layer 2. And again, central on-prem NetEdit web and the web UI and CLI. Static routing only, no stacking, please. And that's no VS, and I also mean no VSF or anything like that. Available as a standalone switch. No Bluetooth dongle. And please, if you're going in an industrial environment, you need to POC and test that. Okay, so the first thing I wanted to show you was the 4100i in NetEdit. So I'm using an early version of NetEdit 2.1. So if I just log in to this. So just shortly log on. So I've got 3 early prototypes of the 4100i. And I'm running an early version of NetEdit 2.1.1, which is, again, a very early beta version as this is recorded. So really just gives you the same look and feel of 4100 as you would expect with anything in NetEdit. So if I just click on to this specific one, which is a 24 port 4100i, you can see that you can see the model, you can see the adjacent 4100s here actually, and I've actually got a client connected here on port 111 doing UBT actually, as a matter of fact. So we can go along and have a look at the config here on this one, as you'd expect in NetEdit, and that those marquee features I was talking about. So in terms of DHCP snooping, you can see that I've got the DHCP snooping configured here for v4 for an authorized server, and then I've got this new command for flash storage, which saves the DHCP bindings in case of a reboot or an outage. So you still save those DHCP bindings, and then I've got v4 snooping on VLAN 2, v3 snooping on v6 snooping on VLAN 3, and if I just go a bit further down, we'll see we've got some of the relay functions here. So I've got relay configured on VLAN 2 for v4 and v6 relay for on VLAN 3, and you can also see I've got a trust on this uplink, because where I'm going to have trusted DHCP servers coming from. And then the other marquee feature I was talking about is user-based tunneling. So you can see I've got a UBT client defined here, my UBT zone, and then my primary controller, which would help me connect initially, and then bring down my bucket map for other controllers if it's configured, and then I've got a port access role, local user role, and then I've got the gateway, and then the role that I'm expecting that's defined on my gateway and in my radius server in this case, which is ClearPass I have, and then I've got in this case I've got one user connected here on 1.1, and really the actual configuration is pretty basic, because obviously I'm using a role to push down onto every interface. So really that's what I really wanted to show you in terms of DHCP and user-based tunneling via NetEdit. So we can carry on looking via NetEdit. I'd like to show you now the web UI. So let's look at this 12 port switch, and open up the web UI through NetEdit. So I just flick that, and then we should get onto the web UI and just log into this 12 port switch. And you can see in this 12 port switch, again, the web UI is very familiar web UI that we do have in Aruba CX. So same look and feel. I'm just going to click into the thermals, because obviously in this type of switch it's quite important. We talked about all the physicals, and this is one of the main things you have to look at, the inlet air sensor. This is where we take a lot of readings and decide on what's happening in the ambient temperature, and here we're good. We've got 25 degrees currently, and we've gone between about 24.85 and just close to 27 degrees. So let's have a look at in the PoE area. It's quite good. We can see this 12 port chassis. It's obviously shown on its side here in the web UI, but obviously as per these slides in my discussion, there's only one orientation. You should really have that in or either back or side and upright. You can see the new LEDs are shown in the web UI as well. That's really all I wanted to show in terms of the web UI and the NetEdit. So let's go across to this 12 port switch and look at some of the other CLI stuff. So obviously there's the quick PoE. So if I just do a show power over Ethernet, we can see that we've got always on PoE enabled by default, and quick PoE is obviously available, and it's quite simple to configure. So I just go if I go into configuration mode and I go power over Ethernet, and I go quick PoE 1/1, that enables it, and then I can just quickly have a look at the power over Ethernet, and we can see that quick PoE is enabled. Again, we can have a look at the UBT. So I had a UBT client on port 11. One on this 24 port switch. If I do a show UBT state, we can see what's going on here. So I've got my primary switch anchor controller, I've got an active and a standby, and I've got a user anchor controller, and that happens to be 10.5.6. I've got 10.5.86. I've got the user anchor controller because I've got a user that's working on here. If I do a show UBT users, all we can see I've got a user, and I think you might remember that MAC address that we saw on 111 of that switch in NetEdit. You can see it's activated and that employee role. So that shows that I've got UBT working on this switch. Now, I also wanted to show you something about alarms. So let me go across to the 12 ports switch and show you something around the alarms. So if we look at the configuration, you can see the default alarms are alarm input 1 is closed, and input 2 is closed. And then if I do a show alarm, we'll see that there is really nothing active. So input 1 is inactive and input 2 is inactive too. So I'm going to first of all set alarm input 1 to be ready for having traps and SNMP, syslogs and SNMP traps. So just configure that, and that's configured that. So if I do a show alarm now, we will see that still both the alarms are inactive, but now I've got the log and trap setting for the alarm input 1. Now I've got a lightweight SNMP trap receiver up here, and I've also got a syslog receiver on my desktop. So when we would see an alarm, I would see that in both of these windows, one as a syslog, one as an SNMP trap. Very important in these environments where maybe industrial environment, SNMP is quite important, and as is syslog, so they're looking for specific alarms to possibly act upon. So let's trigger an alarm now. Normally the alarm is, as I said earlier, closed. I'm going to trigger the alarm and say that input 1 will trigger when it's open. So the basic configuration is alarm input 1, and the trigger is open. As soon as I do that, that will trigger the alarm. That is because I've got no cables connected to my switch, and it is by default open anyway because I haven't closed the loop. So it's like opening a door. Now if I do a show alarm, we will see that now input 1, the alarm has gone into active, and obviously we had this true state for log and trap, so I would expect that an SNMP a syslog and an SNMP trap would be sent. So I can see in the background I seem to have something happening, and if I look first of all at my syslog server, you can see it's quite small, but you should be hopefully able to see I've got an input alarm. IN1 is activated through a log and trap, so, and triggered an open. And then if I go up, my SNMP trap receiver on this desktop has also received a trap for the same alarm. So I've got the input alarm has activated through a log and trap, and if I can look at the OID on this specific SNMP trap. So really that showed you that trap's working, and really the final thing I wanted to show you was some of the really basic diagnostics for power supply and the PoE budget. So if I go into diagnostics, and then I can do a show power just to see that. And here I'm showing, as I showed in the slide deck, I've got the power and the current drawn, and then the power times the voltage times the current, giving me the power. If I had another power source, you would see that too, and the voltage difference between them, basically. Which has to be different for the actual redundancy to be intact in the 12-port switch. So, and finally, last thing I wanted to show you was the actual diagnostics of the power supply. So you can go and have a look at the power supply, and I've got this 12-port switch. I've got 360 watts that's available, but I've said that my actual budget based on the PSUs I've got are 320 watts, and I've configured that as I showed in the slides, and then the available power is 320 watts, which I have on that particular power supply. And then you can see some details about what the status of the actual PSU that's connected. I've only got one PSU, so I only get information on one PSU. So that completes really my quick demo about the salient features of the 4100i ruggedized switch. And now I'm going to hand you over to Ed, who's going to do a bit of a walkthrough around the switch. So over to you, Ed.
Let me know if you see my screen yet.
Yeah, I can see that, Ed. That I can see that perfectly.
Great. So these are the 3D models that we have. These will be available after the GA of September 7th. So I'm showing you a pre-production that I've been able to review and get bullet points on. So unlike a lot of our other 3D the 3D animations that we have out there, these will be out there, the 12 port and the 24 port. We're not going to deal with the PSUs, so just know that you're only going to be able to see that otherwise in the installation guide and getting started. But let me focus on this, the 12 port one. It's the more interesting one at the moment. So the 12 port is, the thing to know about this 12 port is that it's a little bit just shy of 2 kilograms heavy. So it's a heavy box. I kind of, when I have the live one and I show it on my camera, I say it's about the size of most, just shy of your head. It's a gigantic, it's a pretty good sized cube. But here's the thing. It's sealed, it's fanless, and then this is what's really great about the 3D drawings is you can show off the enormous size of the heat sinks that are on this. So this is unlike any other switch that we've ever had in our portfolio. So these are once again industrial. There's even a Kensington lock, location on each of these switches here as well. So this heat sink here. The DIN rail, as we mentioned before, in the back is included with the switch. By the way, when you see this Aruba logo here, that's actually not going to be on the units that we sell. This was a pre-production one, and the vendor was trying to impress us, but then we looked at the cost and we said it wasn't worth it. But as we pointed out, as Kamal had pointed out, this side logo here that you see here is a plastic cover. And it's removable, and we don't have the picture of it shown that way, but you basically snap it off with a screwdriver right here, flat screwdrivers. And then you basically take these 4 screws that unmount the DIN rail, DIN wrap bracket on its back, and then you turn it onto its side and you mount it over here. As Kamal had also mentioned that there were those extra braces, if you had the rear mount, that's what these holes here on the side are for. So on the back of this one, but that's an extra optional bracket at the moment. It's really only going to be needed in really high stress, high vibration environments. We haven't yet made it a product, those extra brackets. So if you ever have an environment like that, let me know. Then I can move forward with productizing that. But we did design it. We did test it, shock mount test it. So we know that it definitely makes a difference. All right, so most environments are like that. But again, back to the switch itself, it's different than most other switches we've ever dealt with before. Once again, this is another one of those switches in our PoE lines that actually allow for a mix. We have 4 ports of BT, and we may have kind of glossed over the point, but the other ports are also AT power, so 30 watts, up to 30 watts in any port. Remember, there's a limited amount of PoE budget. So it's not about all ports can be run at 30 watts or all ports can be run at 40. So, and again, your temperature derating of the PoE, it's not so much the switch that was derated, it was the power supply that had to be derated at higher temperatures. But the 4 ports that here are up to capable up to 60 watts of delivery, and then the other ports here are up to 30 watts of delivery. 2 SFP ports, the alarm junction that is the dry contacts that Kamal was just demonstrating. 2 inputs, so 2 inputs, and then a normally closed and a normally open output on this. On the 12 port, you can actually have the 2 power supplies. I'm going to reemphasize again, it is not doubling of the PoE budget at all. It is merely for redundancy. And you can mix an AC power supply coming in and a DC power supply coming in. And again, the other emphasis, a really important point is you need to use our PSUs because we need to condition the 54 volts that's coming into our switch. So that way the source AC power or the source DC power can be fluctuating whichever is in the range. Those PSUs will condition it out to be 50. They'll step it up or step it down to 54 volts, wherever we need to be there. As we mentioned, the USB-C console port is here. There is a USB-A port for basically the USB-A, the memory stick operations in and out. Unfortunately, we do not have the BT dongle supported on this box at all. So that's going to be one of those kind of situations where you're really going to need to use DHCP to get this box onto the network. Onboarding it with Central is going to be supported further down the line in the 2.4 timeframe, which is October at the moment. And this, of course, here is an RJ45 console port at the moment. So you have your console ports, you have your USB-C, RJ console port, and you do have a Type A USB port here. right? So again, that's kind of the close look of the 12 port box. The 24 port box is your run-of-the-mill 24 port box. It is fanless, and it is once again the mix of, let me situate so you can see it. Similar situation where there's a mix of 4 ports of BT, up to 60 watts, and the rest of the ports are all AT, up to 30 watts. Limited budget in this. It's only just one PoE set. You know, it's basically come on, keep me honest, 240 watts.
Yeah, that's right. You're correct.
Yep. And as we mentioned, that there's the AC input is actually on the front of the switch along with the ports, and then there's that lancet over here for it cinching and putting a tie wrap onto the power cord to keep that there. Especially when you have this switch mounted with the ports down. It's one that is actually pretty much designed to be mounted on the wall, in a flat design with the ports facing down. And again, like the 12 port, look at the size of those monster heat sinks on this thing. All right, so that's a pretty serious heatsink design. There's no fans, and as somebody had asked me the question, is there a warning label for hot temperatures? And the answer is absolutely. If I can get there.
It's the one on the left.
Yeah, I'm trying to manipulate the picture. So this is indeed a warm product. Remember, I've always kind of usually said that our campus switches, if it's uncomfortable for a human being, it'll be uncomfortable for the switches. Well, this switch can go up to 70 degrees centigrade. So that's well over comfort level in any situation. All right, so just know that you're going to be dealing with pretty warm temperatures here. But again, this can be mounted in those harsh environments. It does require airflow. Both of them do. So just remember that it's not like it can be in a completely oven. It is spec to operate up to 70 degrees ambient. When it gets above those temperatures, all sorts of nonsense can happen with the switch. So you got to be careful about that. If you're going to have a NEMA enclosure, make sure it's vented. I'm actually engaging with the NEMA enclosure vendor who actually works with our access point group with the APs and stuff, Ventev. So they actually produce a NEMA enclosure with a built-in temperature-sensitive fan to kind of force air through the box itself. Right, that's pretty much all they need to do there.